Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Muhammad bin Rizwan Izal and my matrix ID is 205481. Today, I will start the presentation of our topic, which is the engineering application of thermodynamics in a refrigerator system. Our team consists of Nashran, my friend Vickness and me myself. So first of all, we start with the description. In a refrigerator in our home that we use in our daily life, they use a refrigerant. They are act as a medium to heat transfer from the inside of the refrigerator into the outside. The transfer of heat in the system itself use the application of thermodynamics, which is the first law and the second law. So I will continue our explanation with the fundament about the first law that is applied in the refrigeration system in our daily life. So it is stated that in the first law of thermodynamics, we know that heat is a type of energy. And in thermodynamics itself, it is related to the conservation of energy. Besides that, we know that energy cannot be transferred or cannot be created or destroyed, but only can be transferred from another type of energy into another type of energy. For example, from electrical to thermal, from mechanical to thermal also. Besides that, there are also a formula that are related to the first law of thermodynamics, which is the energy balance equation. The basic equation is that E in minus E out equal to E system. So in the refrigeration system, the energy transfer used is from electrical energy, which is from the power plug that we have in our home. The electrical energy will change form into mechanical energy, which is produced in the motor of the refrigerator, which contains the piston. Then the mechanical energy will change form into a thermal energy in the form of heat, which is produced from the work in the piston and also the heat that are contained in the refrigerator. So the second law will be continued by my friend, Vickness Warren.
Thank you very much, Adam. My name is Vickness, son of Kubusami, with matrix number of 207228. Will be now explaining the fundamental principle of second law of thermodynamics that is related to the refrigerator. So the basic principle of second law of thermodynamics states that energy have quantity and quality, which means energy have magnitude. So transfer of energy, to be specific, heat energy, happens from hot to cold objects, area, or reservoir. The example of application that uses second law other than refrigerator is Carnot cycle and heat engine as well. Other than that, heat transfer can also happen from cold to hot object, area, or reservoir. This might be seen as this concept is disobeying the principle of second law, but it doesn't. In order to transfer the heat energy from cold to hot object, area, or reservoir, work will be needed. And the work will be done by the any part of the system using the energy that is supplied to the whole system. So the refrigeration cycle starts at the expansion valve. The refrigerant will be flowing with high velocity, but the flow of the refrigerant will be disrupted at the expansion valve, in which the pressure, the velocity, and the boiling point of the refrigerant will be reduced. This will cause the refrigerant to become cold, low pressure liquid. So this refrigerant will be flowing to the evaporator coil, in which refrigerant will absorb all of the heat from the inner part of the refrigerator. In this case, second law of thermodynamics is applied as the heat is being transferred from the very hot area to cold area. Now that the refrigerant have absorbed the heat, it will become cool, low pressure gas. Now, it will flow to the compressor, in which the refrigerant will be compressed. Compressor will compress the refrigerant by doing work. The work will be done by the motor that is in the compressor, and the motor can do the work by using the electrical energy that is supplied. After this process, the refrigerant will become hot, high pressure gas, and now it will flow to the condenser coil, in which the refrigerant will be releasing the heat to the surrounding. In this case, the second law of thermodynamics is applied again, as the heat is being transferred from hot to cold area, which is from condenser coil to the surrounding. And for Additional information, the condenser coil will be placed at the back part of the refrigerator. So then the refrigerant will become warm and high pressure liquid. So this refrigerant will flow to the expansion valve again, and these cycles repeat again and again. So this is the graphical representation that is showing the refrigeration cycle. So that's all from me. Next, my group mate Cairo Nashran will be explaining the thermodynamic analysis on refrigerator. Thank you.
So next we are going to discuss about thermodynamic analysis. So the we know refrigeration using to cool down the temperature, and then the system will compress the vapor refrigerant. That's why the system can be called vapor compression refrigeration system. So in this, all of these part are connected by connecting pipe. So we can consider is a closed system. So first of all, we have a evaporator. This component are using to the cooling process that take place, which is it will absorb heat from the outside into refrigerant. So the surrounding will be cooled down, and it will be flow into the compressor. So since the compressor is the very important, it will play the important role in the refrigeration system. At the inlet, we have a low pressure and low temperature of vapor refrigerant. In here, look at the figure we have in here. The compressor will start to compress the refrigerant. We know it will require work. So to apply the force, the work is come from mechanical energy, which is applied by motor. We have a motor in here, and then the mechanical energy is converted by electrical energy that's supplied by power supply or electrical sources. And in here, we know about the vapor refrigerant will start to compress in the compressor chamber. It will heat up because the particle in here will increase the pressure and increase the temperature. At the outlet, we will have a high pressure and high temperature. So from the theoretical, we will have these equations to steady flow energy balance equation for compressor in just for the theoretical. And then we will have high pressure and high temperature at the outlet, and interflow into to the condenser. At the cold condenser, it will absorb the heat, and then convert the vapor into the liquid, and then uh, convert it to the liquid by external sources. It will flow. It will flow in and enter the expansion valve. At the expansion valve, the high temperature and high pressure of liquid will be expanded, and as a result, it will lower the temperature and lower the pressure of the liquid. And in here, we will have the mix, which is we will have a low temperature and low pressure of liquid and vapor. And then it will start to flow back into the evaporator, and the refrigeration cycle. It will be repeated again and again. I think that's all from me. Thank you.